So good afternoon, everybody. Good morning, good afternoon. Just know that if you're seeing this video, it is too late. I'm actually currently, if this is being shown, being a proctor for a Civil 250 hydraulics quiz, as fun as that sounds. So I'm going to be introducing to you the paper that I've chosen for our term project and a little bit of the work that the authors were able to do in this conference paper, as well as some of the work that I hope to do throughout the term in order to build upon what was already done. So the title of the paper is Stability of Railway Embankment in Saturated and Unsaturated Conditions, and it was published by the University of Malaysia, University of Technology in Malaysia, for the purposes of a conference. And you can see the many authors' names on screen. I will do them the favor of not mispronouncing. So we're going to be following the story of this conference paper from the University of Technology. The study kind of acknowledges the implications of a changing climate on slope stability issues, and more specifically, it's investigating the interplay between slope stability and live loading in a linear infrastructure application. So what they did was they wanted to take a look at the impacts of precipitation, the infiltration impact, and the unsaturated behaviors in an embankment. So they collected necessary data for the materials from real soil that is relevant or within a certain area of the site in Malaysia so that it would be accurate. They took it into the lab and they ran a series of our standardized soil tests to extract parameters. So with that, they also took some real climate data from the meteorology station in Senai, Malaysia, which is conveniently run and operated by the university from which this paper originates. So they were able to get some great high quality data. And what they looked at specifically was total precipitation by day and by month. And so they elected to choose the month pictured circled July and December, where both the least and most precipitation took place. So the scope of this paper, they selected just to take a look at 2 months. But what they had to think about first off was an infiltration ratio or a runoff ratio. So for this, they took a look at the literature, and they saw numbers such as Eng et al., which you'll see later referenced, considered a 60% infiltration to 40% runoff, while Rijardo et al., they suggested an infiltration value anywhere between 40 and 70%. So for an undisclosed reason, this paper chose to use a 70% infiltration rate, which is kind of pictured in these graphs A and B, where you can see they've segmented it into the 30% runoff, 70% infiltration. So special care was given to embankment design and embankment geometry. So in reality, the majority of embankment failures are actually a result of design error per Gu and Tan 2006, as referenced in the paper. The researchers wanted to ensure the use of idealized embankment geometry so as not to contribute to an inaccurate numerical analysis. The workflow on the right illustrates it's a little bit of a flow chart that shows with kind of how they worked through the problem in terms of a numerical methods sense. So they start off with a transient water flow analysis in SEEP-W, then they apply the results of their transient flow analysis to slope-W, and then they have the two cases which diverge at slope stability analysis using a limit equilibrium method, Morgenstern-Price, I believe, and they go on for the unloaded condition and the loaded condition, and then join together at the end for the sake of comparison. So here are some of the inputs. First of all, these two tables were perfect. They're a great reference. They include the mechanical characteristics of the subgrade, which were obtained from the laboratory testing. You get your liquid limit, plastic limit, gravel percent, silt, on and on and on. And as well, they provided the hydraulic characteristics, the saturated hydraulic conductivity, the N value, the M value, residual volumetric water content, and saturated VWC, which we are all familiar with from some of our work in Excel and past tutorials. And they published with it these results. So these first figures kind of show, on the left case, we have the case of loading through July, accounting for both rainfall and accounting for vehicle load. So it kind of demonstrates how the factor of safety decreases continually between rainfall events as we have this rainfall infiltration, and we don't necessarily have the time for all that water to seep back out and settle at a kind of stasis. And so due to decreased shear strength, positive excess pore pressure, or decreasing matrix suction, this is all contributing towards this lowering factor of safety. So the rightmost figure shows the influence of applied load, or the leftmost figure, sorry, and the rightmost shows just with the rain considered. So let me just get these up. Perfect. So here you can see the first figure demonstrates factor of safety from the rainfall events and loading and the decreased shear stress, but here we actually have their end results. These are their worst case scenario failure surfaces for both the loaded and unloaded condition, as well as the factor of safety. I apologize for the graininess of these figures, but these were also how they were presented in the conference paper, so I did my best to zoom in. So for the unloaded condition, they were able to get a factor of safety of 2.876, which might seem okay, even though we aim for that 3-round. But in the loaded condition, you see that with all the rainfall, you get pretty close to a failure point with a factor of 1.654, which doesn't leave a lot of wiggle room. So proposed course of action. The first thing I would like to do, so the paper does a great job of illustrating the impacts of pore water infiltration in combination with loading on the impact of, and the impact it has on factor of safety and embankment performance overall, and it serves as a great opportunity to build upon and for further exploration into the topic. So for my term project, I would like to recreate the table outputs in order to validate and ensure that my model is accurate. I'd like to undertake 2 or more of the following. I've chosen 3 ambitiously, and if all 3 work out, that'd be excellent, but I want to give myself some room for some error. So first of all, I'd like to explore a scenario with a train exceeding load limitations. So certainly there are cases where load limitations are skirted in order to cut costs or what have you, and it's not always in the best interest of safety. So I'd like to take a look at a realistically overloaded train, so take a dive into the literature and see what kind of happens in these scenarios and say what kind of percent overload do people actually get away with if they do. And if not, I'd just like to play around with that and really see how bad it can get. Second of all, I'd like to explore a scenario with extreme rainfall, whether that be a 1 in 50-year storm, a series of days back to back to back with extreme precipitation, and just see what a one-off storm event could really do to the factor of safety, because as you see in the real climate data, sometimes it's spaced apart days between these big events, but what if we got hit with something really bad, perhaps not all that common, but something really bad. And third, I'd like to explore varying values for rainfall infiltration. So if you remember on the second slide, they took a look at rainfall infiltration values and referenced a series of competing thought processes from the literature before choosing 70-30. So I'd like to kind of play around with that and take a look at the conservative end as well as the riskier, as well as the less conservative end, and kind of see how that interplays with our factor of safety, and ideally come up with a best and worst case scenario for a more informed image. So I hope you enjoyed my little outline, and I hope it was enough information for you to get an idea of what I hope to do with the paper. If you have any questions, please feel free to email me, or if you'd like to take a look at some of the reference material as well as the papers referenced within the conference paper, these are the following, which I mentioned during my talk, and I would gladly provide you with the full list if you were more curious.